Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by Techstrong and Bionic. My name is Cody J. Brown. I'm the host of Techstrong Learning. So we have an exciting speaker ahead, but first I have a couple of housekeeping notes to cover. First, today's session is being recorded, so if you miss any of our session or you have to leave early, the on-demand recording will be made available shortly after we conclude our live webinar. If you have any questions, we want you to direct those to the Q&A tab on the right side of the screen. That's also where you'll find the chat tab where you can engage with your other fellow attendees. Finally, at the conclusion of our webinar, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. Our topic today is improving AppSec with application security posture management, and I'm joined today by Matt Rose, Chief Architect at Bionic. Matt, thank you so much for being here with us, and I'll give you the floor.
Oh, thank you very much. Very excited to present to everybody today the topic of improving AppSec with application security posture management. I know that was already mentioned, but I figure I'd say it again for emphasis. I'm Matt Rose, and we're going to walk through kind of a journey through what AppSec is as it relates to application security posture management. The big thing to think about today is this is about the security of our applications everywhere, not just in testing, but more primarily in production. How do you secure your production apps today with application security posture management? With that, we'll get started. So in 2021, now 2022, code changes are happening more than ever, 100 times more than infrastructure. Everybody is moving to the cloud. Everybody is introducing new capabilities, new microservices, new different functionalities with APIs and things like that. So exponential code changes are happening quicker today than ever before. And that's really based on this continuous delivery process. We all want to go fast. Well, guess what? You got it. We're going fast with the release of software in many different ways. But there's a problem with this. How do you map all the many changes with services, dependencies, APIs? There's an explosion in drift and the dependencies that are associated with drift. What drift is, and when I talk about drift, I'm not talking about infrastructure drift, which people are, tend to be pretty familiar with these days, talking about cloud infrastructure drift, the services of your cloud infrastructure changing, but this is more about the application services changing at warp speed. How many attack surfaces exist today? How many exist in 10 minutes, in an hour, in 2 days, next week, based on these aggressive continuous delivery cycles? Think about that for a second. Think about your processes and how you're releasing code. And do you truly know what is changing in your production environment? Think about that. So applications are like art. You think that you're deploying the Mona Lisa, the quintessential masterpiece of the art world. You've done all your due diligence. You've architected the most beautiful application in the world, and you think it's perfect. Well, guess what? It really looks like your 5-year-old's rendering of the Mona Lisa. The reason is that this is the concept of application drift. You think you have something in production, but you're not monitoring it. You truly don't know what it looks like. You have that assembly line of your CI/CD process, releasing new microservices, new dependencies, new features, new functions, but you're not keeping tabs on what it looks like. So your masterpiece morphs into a representation of what you think it looks like. This is the main concept that we're going to be digging into in a lot of different ways as it associates with application security posture management. And the acronym I'll use is ASPM. Probably a new term, new concept for a lot of people. It's starting to gain a lot of traction in the industry, but think of ASPM as a way to understand if you have art or a representation of art for your applications. So drift, that concept of moving from the Mona Lisa to the child's version of the Mona Lisa, really falls into 3 areas: security risk, data privacy risk, and operational risk. We're going to start with security risk. Security risk is really about the new attack surface. How is your attack surface changing? What are all the entry points, exit points, third parties, and vulnerabilities in your application? Do you have unauthorized access into your application? Or are you mismanaging secrets in code? The security risk is represented by, everyone's favorite warden from Shawshank Redemption, when you're actually uncovering the hole in the wall where you found somebody escaped from some information escaped from your application. You probably have the same look on your face when you say, oh my God, what happened? What is this risk? How do I go about finding this? Application security posture management can help you with this problem, can help you identifying what the new attack surface looks like, who has unauthorized access to the application, or what has unauthorized access to the application. How are the secrets in my code being managed? Are they being managed correctly, incorrectly? Moving into our friend from Office Space here about data privacy, about your personally identifiable information. How is PII data being exposed to in your applications? Do you truly know every path of PII within your application? And when I say PII, I mean personally identifiable information. It's a tongue twister there. Or PCI, payment card industry exposure, the credit card data that you're so concerned about, or healthcare type data. Do you know the risk associated with this type of data and where it's going in your application? And when I talk about the application posture, is it strong in terms of identifying and protecting this type of data based on the architecture? So the last thing is operational risk. The last thing we want is your e-commerce application or your mission critical application going down by a misconfiguration or a oops, I didn't mean to do that type aspect. And that's where operational risk is really the concern. Downtime, availability, reliability and continuity, business continuity. How do I make sure that my applications work as expected all the time to run my business? We're going to dig into a lot more of these areas in a few slides, but think about these three areas: security risk, data privacy risk, and operational risk in your applications. And I had to mention Woody and Buzz there in the bottom because operational risk is everywhere. So a real life example of security risk. We have our friend here, Mr. Homer J. Simpson, seems to be sharing Ned Flanders' credit card data, but this is actually a serious example. A developer adds credit card processing to an application. He thinks that this is required. It is required, but the concept here is the application he's adding it to was a lunch menu, and the lunch menu was for ordering lunch. And it was not a mission critical service web application. It was just showing what was for lunch today. But he added credit card processing to that web application in order to allow for people to not only look at what's lunch, but to pay for their lunch. So now you've taken a service that wasn't doing anything and you've added credit card processing. Little did he know that that web application had a critical CVE. There's no way in the world that you should add credit card processing to an application that has a critical CVE. The crux of the situation here was that security knew about this CVE, but they deemed it not important because all you did was look at the lunch menu. There was nothing associated with PII data or credit card processing or all those type of things. This was drift in the application. Somebody thought that it was a good idea to add this piece of functionality to an application, but didn't think about the security risk associated with it. So this is a very simplistic example, but a real world example when you think about drift and security risk. Thank you, Mr. Homer, and I'm going to go order lunch with Ned Flanders' credit card. Second example is operational risk. Those damn cloud computers, they're everywhere. They get in the way of everything: birds, planes, space shuttles, whatever you want. But cloud migration for an application was finalized. This was a lift and shift type of activity for an organization. They took a mission critical application and migrated that to the cloud. All their I's were dotted, T's were crossed. They made sure everything for that cloud infrastructure was perfect. They ran all the tooling, the testing, the cloud security posture management. They made sure everything was correct. However, they missed an application dependency within the application architecture itself. This caused 6 hours of downtime on a critical e-commerce application. And a critical e-commerce application, we're talking a ton of money here. This was a simple mistake. Everybody focused on making sure that the cloud was correct, but they did a lift and shift and didn't make sure the application architecture was correct. And this drift of dependencies or dependencies misconfigured, dependencies not connected and wired up correctly is a huge problem because you're moving so fast with that CD process that you talked about earlier that you may actually miss something, and something that works in one arena or one environment may not work in the next environment. Just another example. We have a couple more coming up, but just wanted to kind of map in the risk and the operational risk and the security risk associated with drift in your applications. So why should I care about this? And a lot of these types of vulnerabilities or hacks that I'm talking about are multifaceted. It's not I did A and B happen. There's a bunch of things that kind of go into these equations. A very well-known or highlighted and press covered hack of the past year was from Peloton. In 2022, applications APIs are the fastest growing primary attack vector. This hack specifically shows that. So Peloton, and again, we're talking about the architecture of the application, how it's put together, how it's basically configured correctly. Peloton had an unauthenticated API with a PII dependency. Again, multifaceted attack here. Unauthenticated API plus a PII dependency. That means the two things were talking to each other, like this little graphic kind of shows here. So what happens next? Somebody was able to identify and hijack this unauthenticated API, this nefarious dude. He came out and figured out how to actually put the pieces together, which resulted in thousands of individual customer PII data records being compromised. So this is a multi-stepped approach where one thing happened, another thing happened. Somebody found out that putting those two things together actually caused a major breach for an organization. This is very, very hard to find for organizations because they are pushing out to their very complex application all the time. They don't know how many dependencies they have, how many third-party APIs they're talking to, or third-party libraries. They are just pushing out for functionality to meet the requirement, but not truly understanding that beautiful picture of their application represented by the Mona Lisa on the first slide. This is why you should care. You should care about the complexity and the architecture of application causing risk that you don't even know about. So everybody has a cloud initiative today. Maybe not everybody, but pretty much everybody. Everybody is buying the best of breed cloud security posture management platforms, configuring a cloud in the correct way. That's why we have this beautiful cloud that looks like it's the shining example of a secure cloud. You know, everything is configured right, everything is wired up right. But what is represented here is my app living in the cloud. So the cloud infrastructure supports an application that is my application. Yeah, the cloud infrastructure can know a few things about the application, but it's very, very kind of high level. They don't know everything about this application. So in a real world example, we have my app actually looks like this representation on the right. All the data flows, all the services, the potential for risk and critical CVEs and critical vulnerabilities within the app itself. So if you have a secure cloud, it doesn't mean your secure application, your application's architecture is secure. You know, my app is actually composed of hundreds of internet-facing services, microservices, APIs, dependencies, and interfaces. There's a lot of stuff in there. And just having that as a small entity within your greater cloud ecosystem, you're truly not securing your app. You're securing the infrastructure or the environment around the app. A silly example or a silly analogy I always like to say is the cloud architecture is a shoebox. The app are the shoes within the shoebox. You are concerned about those shoes just as much as you are the box that's protecting them, but you want to make sure that the shoes are, in fact, protected. Moving on. So cloud security posture management is only half the picture. CSPM is really about cloud infrastructure. CSPM is a great technology. It does a lot of great things. People are happy with a lot of the vendors in the cloud security posture management space, but it's about cloud infrastructure, the host, OS, the process, the cloud APIs, logs, events, config, containers, all of the things that make up the kind of architecture, the environment that your app lives in. But your app associated with application security posture management is made up of binaries, code, APIs, libraries, config, database queries, all of these. There's a ton of things in there as well. And if you're just looking at from a cloud security posture management lens, you're missing a ton of risk. We find these two things are very complementary, where it gives you the same level of information, but just with a different view or a different lens. Are we looking at the infra or the app data? So the type of things that, a CSPM versus ASPM really look at, CSPMs look at anomalous clients trafficking, unencrypted S3 buckets, suspicious OS processes. I'm not going to read every example here, but you can see that we're very infrastructure specific on the left. But on the right, we're talking about hard-coded secrets, unauthenticated APIs, data flows, CVEs, PII data leakage. We're looking at the application architecture compliance and security rather than cloud infrastructure compliance and security. So having one without the other, it's like Batman and Robin. You need both in order to be secure. You need a dynamic duo for the infra and the app level details at the very granular level. Having the granular level in the cloud, but without the app, is not a completely secure infrastructure and application environment. I know we call this, application security and posture management as the title. So one of the things that everybody, when they hear about application security testing or AST or STAR AST, is scanning. AST scans for everything. It's basically just scanning for tons of different types of things, but it's kind of like a blanket scan. AST can't find or can't scan for everything. It can't scan for things like every data flow in an application. It can't scan for multi-level type attacks where an internet-facing API is basically connected to a web service with a critical CVE that's also touching PII data, because that may be unique to your application architecture, not something that everybody knows about or everybody has the same problem with, like an OWASP top 10 issue with a SQL injection and cross-site scripting, which has a certain structure. AST can't scan for the things that are unique based on the application architecture, where application security posture management can look for those things in many different ways because it understands the whole picture, not just a small piece of the picture itself. So what is application security posture? I'm going to read this because I want to make sure we really get it down. It's a complete and comprehensive risk profile of an application architecture that includes all services, APIs, dependencies, attack surface, and data flow. A service in application security posture is a web application, a third party, a database, a message broker, and the communication of these services within the application ecosystem or architecture itself. So if you see here, we have gateways, search functionality, APIs, third party with Salesforce and CenterGrid. This is the posture of an application from security. You can see everything that's happening on this based on the analysis and reverse engineering of the code artifacts itself. When I say code artifacts, in the Java world, we're talking WAR files, jar files, EAR files. In the .NET world, we're talking DLLs and their associated config files and environment variables. But this gives you, we basically explode out those artifacts and make this architectural view of your application. This is application security posture. Is your posture standing up to the threats that are facing it on a day-to-day basis? Is it standing up to the potential for drift from one version, the Mona Lisa, to the child version of the Mona Lisa? It's a question you need to ask yourself. How do I know what's in production? How do I know it's what I expect it's supposed to be? So, question for the audience. How do you get visibility of your application security posture in production? You can use the chat window and ask the questions. We'll go into the Q&A. I'll just look off the screen because I have a multi-mon system here. So question, if I can go into some details, but it's much better when we have audience participation. How do you get visibility of your application security posture in production? Is there a process? Is there a policy? Is there a piece of technology or tooling that you use? If anybody has any examples that they'd like to share, I'll give a pause for a second. But there's no really wrong answer here. This is just how you do it on a day-to-day basis. Well, it doesn't look like we're getting anything, and I don't want to bore everybody sitting here watching me. So we'll move on to the next part of this, and I will talk to this without the QA audience. My next screen. So what I hear from customers is that the elephant in the room are these players. You have your CMDB, which is basically all the information, but it's not updated. It's basically a snapshot in time, but it's not real time. If you're releasing 100 times a day based on that CI/CD process, your CMDB is not being updated. It's not up to date. And if there is a 0-day like log4j, you're not going to be able to go back and reference that CMDB. It's going to be the detective work. Oh, we have SonarQube scanning. I have AppSec, Sumo Logic, and a SIM. Okay, we have some examples coming in. These are all represented. Those are great examples too. But when we're thinking about understanding everything, it's typically around CMDB documentation. We also have, the AST scanning technology, SAS, DAST, IAST, RAST, CSPM, CNAP, and MyAS is probably something that is very important to everybody as well. But all these elephants together are not updated. They're not real time, and they're only giving you a snapshot in time. So thinking about documentation, how often is your documentation updated? Is it updated daily? If you're doing 100 releases a day with microservices, are you updating the documentation? Probably not. If you're looking at using SAST or DAST or IAST, you're looking at specific types of vulnerabilities. You're not understanding all the services, all the data flows, how they interact, what the dependency are, what service depends on what dependency, how does a change produce additional risk. We have accurate application visibility is something that nobody ever said. Everybody, I've seen it. I've been in a room and say, do you feel like the visibility into your app in terms of risk? And I get a lot of laughs, a lot of rolling of the eyes. It's not really something that people feel comfortable with. And they try and, stitch together all these technologies with all the data that comes out of these technologies and try and get a holistic understanding of the application visibility associated with risk, but it doesn't work. And that's where application security posture management comes in. It is the kind of bleeding edge in understanding everything associated with your application architecture. So where does ASPM fit in? There's probably a question everyone's saying, that's great, Matt. You've said all this stuff. It sounds fantastic. So typically you have your dev environment and, you're talking AST tooling. That's where the check marks and fortifies, the whole concept of shift left, even Veracode, even though it's more of a binary analysis, it's the developers' tools. Everybody wants to get SaaS type tools into the developers. That's on the left. And then the build, yeah, you can integrate your SaaS scanners and different types of components such as SNCC and Black Duck for SCA into the build process. But in production, you really have two pillars, two very important pillars. We have the cloud security posture. Cloud security posture management vendors that probably people are familiar with are Wiz, Prisma, Lacework, and those are about infrastructure drift, infrastructure risk, storage risk. Are my S3 buckets encrypted correctly, so on and so forth. But the apps that live in that cloud security environment or the cloud environment that you've used these CSPM vendors on is the application itself. And that's where application security posture fits in. It's about architecture and code of the application itself, not the infra, but the app level. And this really kind of follows around application drift, application risk, and data privacy. So you have the security testing on the left in the dev and the build, and then in the production environment, again, the Batman and Robin, the dynamic duo, are application security posture management and cloud security posture management. Because with those two working together, you have the complete lens of everything associated with your application. Without the two, this is something that is I think a major problem for a lot of organizations, is that they feel their cloud is secure and they do a great job securing their cloud, but they kind of forget about the app level drift, the app level dependencies, and how changes could potentially cause major problems for an organization. If anybody wants to jump in the chat, any questions up to this? I'm totally open. Somebody asked that, simply there's too many acronyms. I know CV, but ASP, I am LOP. ASP, Application Security Posture, is what we're using that acronym for. So ASPM, Application Security Posture Management Capabilities, really have 6 main pillars. Continuous architectural dependency mapping. If you've used a cloud security posture management solution before, you basically can see all the services and how they connect. With ASPM, or Application Security Posture Management, you have that same lens, but at the app service level that we talked about before. Web services, databases, message brokers, third parties, all of the components that make up the application. The second piece that ASPM really provides is that dynamic software bill of materials. So everyone's familiar with the concept of an SBOM, a software bill of materials. But typically that's something that is either component-based, something that a software composition analysis solution basically provides you, but that's just about that open source, package that's being scanned. Or it's something that is, maintained in the CMDB, that you basically have a SBOM that basically lists everything at one point in time, but it's not continuously updated. What ASPM provides you is an up-to-date dynamic bill of materials based on a release of code. So every time you're doing a release of code to your production environment, you have the ability to see everything that's in that application. Libraries, frameworks, databases, everything, dependencies, third parties, everything associated with that application. The other big kind of pillar of application security posture management is drift detection. I have the Mona Lisa picture. I have the perfect masterpiece of an application, but all of a sudden something changes, and all of a sudden we have a misrepresentation. We think we have one thing, but we have another. Understanding drift and how a change in a service, a change in a dependency could potentially cause major risk to your organization is something that people don't have at the application level today. One of the other things that I'm very passionate about, and this is my background, if people haven't seen any of my podcasts or my Bionic Uncensored, is that I come from a SaaS background, where SaaS is static application security testing, where it's looking for structured type things. And data flows always have a structure, an entry point, an execution point, and a potential validation routine between the entry point or exit point, source and sink, however you want to call it. But that's just a lens. It's not giving you the full picture of all data flow, an automatic data flow classification that, this is a data flow that consumes PII data or PCI data, or this is a potential risk based on PII data touching a third-party service that is internet-facing. These are all things that you need to know about, because it's not just about the known vulnerabilities, it's about the potential unknown vulnerabilities that are unique to your application architecture. And then everybody needs a risk scoring. And risk scoring is kind of it's a science. It's interesting to say that there's always risk scoring associated with any type of vulnerability. It doesn't matter what type of security tooling you're actually using. But when you think about risk scoring of an application architecture, it's multi-level, where you have, again, that example I keep giving, which is, an internet-facing application that is basically has a CVE that is also touching PII data. And that risk score goes way up because there's real risk there. There's PII data, so there's basically data that of your customers, of your employees, all those type of things, maybe even compliance concerns around PCI or PHI. But thinking about how that would actually be exfiltrated from the system through a critical vulnerability and internet facing, the risk scoring goes way up. And most of the vulnerabilities that you hear about today have multi-level. So thinking about the Peloton hack from a few screens back, thinking about that, it was an unauthenticated API that was touching PII data. Just having an unauthenticated API is bad, definitely a bad thing. But if that unauthenticated API is also touching PII data, that's really bad. So that, as an example, the risk score would go up. And risk score is really around prioritization. If something has a higher risk score, it's probably more dangerous. So you want to focus your attention there. I always like to say there's two variables for risk. There's impact and likelihood. So impact is how bad is it if this gets breached? Likelihood is what's the likeliness that somebody's going to find this? So the more complex one of these hacks basically becomes, the less likely, but the risks may go up, or vice versa. So you always want to weigh the vulnerabilities, and that's what risk scoring brings to the table, is impact and likelihood. And then the risk impact analysis. How does this change in drift? How does this change in application architecture affect the risks for my organization? Is it operational risk? Is it security risk? Is it data risk? How is this going to be basically presented to me in terms of a breach, a hack, or just something I need to fix on a day-to-day basis? So all these things working together are paramount to the security of your applications as they live in your production environment. Again, you got to make sure that you actually know what's living in your production environment, because a lot of times people just assume they know what's in there. So a real life example of data privacy list. We have Dr. Evil, air quotes, minor code change. The developer pushed a minor code change. He said that this minor code change does not touch any type of PII data. Okay, sounds good. Go for it. Dr. Evil, go release your code. It's just a minor code change. Well, come to find out that this minor code change actually did touch PII data and sent 401k financial data to an unauthorized third party. Somebody logged in and not only saw their financial data, but somebody else's. This minor code change was a drift in the architecture, and it actually touched PII data. Developers swore on their life that they didn't, access or use or do anything with PII data. They just assumed that everything would be fine. So thinking about this is another example of data privacy, that a minor code change could drift the application, a secure application, into an insecure state. So final thoughts, and then hopefully there'll be some questions. I see some popping up, and I'll address those, because I always like, people jump in with questions. I'll do my best to hit on as many as possible. That CI/CD, continuous integration, continuous delivery processes introduce drift and hidden risk. Drift is hidden risk or unanticipated risk. How are you managing that at the application layer today? Map and manage all application dependencies. Your applications are a huge puzzle. There's many different pieces. The pieces of the puzzle are called application services, and they all interact and fit together with square edges and data flows and connections. But how do you manage that? How do you map that and understand what's actually happening? You basically have a Visio doc or some sort of representation or a whiteboard drawing of the app and say, that's what my app looks like. But when it's in production, when people are actually accessing that to do whatever functionality it's actually doing, are you sure it's doing the right things? That's how a map and managing the dependencies really help. Your secured cloud environment does not mean you have secure applications. Yeah, you're putting a barrier around it in terms of the infra, but a lot of the things that are happening to your applications are unique to their functionality, to the way they operate, to the data they touch, to the intended purpose, whether it's internet facing, internal facing, whether it's basically using services that have critical CVEs. Make sure that you're securing your application just as well as you're securing your cloud infrastructure, because it doesn't matter how much money, time, and resources you spend on securing that cloud. If the application architecture is misconfigured, you're still going to have issues. And you think beyond application security testing, you know what I'm talking about, the good old OWASP top 10 finders, the SAS, the DAS, the IaaS type vulnerabilities that are looking for those OWASP top 10 vulnerabilities, the SQL injection, cross-site scriptings. Think about just that cloud infrastructure environment. What do you see? What are you missing? You're missing a lens on the application as it exists in your production environment. These are the final thoughts I had on application security posture management. I love the questions. I see some coming in. Are we going to manage these? Let me see what I can see. Any other questions coming in? Let's see. Hello. We got a bunch of hellos.
So Matt, in the Q&A, I'm seeing one. It says, does putting SCA SAST in a CI/CD pipeline slow the app delivery, or what's the best way to implement SCA SAST DAST for a large scale application?
Well, again, we're into the AST space here, so we're looking for vulnerabilities. If you do anything in that CI/CD pipeline, it's about really what tool you're choosing. Because again, sometimes they scan in the environment, sometimes they scan outside of the environment on a client server type of architecture. So thinking about the vulnerabilities is just a question of which technology you're using, and really not to slow the process down. One of the cool things about application security posture management is that it's collecting the artifacts and doing that analysis off of the CI/CD pipeline. So you don't have to worry about the compute time or the complexity of collecting the code and scanning it on the CI orchestration layer. You're basically doing that in the environment. But thinking about CI/CD and SAST and DAST is something that's in testing. It's not integrated into a CI/CD pipeline, because I do see this question now. So software composition analysis and static application security testing, probably a best practice to be in there. But I find that a lot of times that's where you find vulnerabilities, but they're fixed in the developer environment itself. But again, when you're thinking about those technologies, they're just looking for structured type vulnerabilities that every scanner is really looking for. It's looking for OWASP top 10 issues. I mean, yeah, everybody can yell at me, scream at me, however you want. Anybody that's using SAST is pretty much just using it for OWASP top 10. That's the end of the day. Most of the hacks that we're talking about, like the Peloton hack, the unauthenticated API that's consuming and using PII data, that's not going to be found by those tools. It's not, because that's an unauthenticated API consuming PII data that's stored in a database. That's not going to be found by SQL injection, cross-site scripting, or anything in an OWASP top 10 type of scan. So hopefully that helped. I'm a big proponent of integrating as much as possible into the CI/CD pipeline. So, yes, SCA, yes, SAST, no on DAST. That's something that has to have a running application in your testing QA arena.
So, Matt, I'm not seeing any more questions at this point in time. So I can give away a couple of gift cards while we give our audience a few more minutes to send any in. So these are for 4 $25 Amazon gift cards. Our first winner is Benny Z. Our second winner is Olabodi M. Our third winner is Juha S. And our fourth and final winner is Susan H. So please keep an eye on your inbox to claim that gift card. And if you don't receive an email, just check your spam folder. Also take this opportunity to remind our audience that this session was recorded. So following this webinar, you'll receive an email with a link to access the recording on demand. You can also find it on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. Matt, I think we have exhausted all the questions we've received today, so I'll give you the floor one more time to leave us with any parting thoughts before we close out.
No, absolutely. Thank you very much. So I want to talk, really final thoughts. Your applications are built on code. Code is the definition of your application. If you're not looking at the code of your application as it looks in your production environment, you're vulnerable. It's just, there are potential risks. Things are going to change. And if you just look at it in that dev arena with the AST scanning solutions, you're going to miss the unique vulnerabilities, the really hard to find vulnerabilities, unless you have an architectural risk solution such as application security posture management to find the hard to find things, the things you don't even know about, know to look for. Because if you don't know to look for it, you're never going to find it. That's what ASPM brings to the table. It finds the things you don't even know how to look for.
Well, Matt, thank you so much for taking the time to join us today and for going in such depth on this topic. I really appreciate all the work and thought that went into the presentation itself. So thank you. I also love the memes.
Thank you very much.
Of course. I'd also like to thank Bionic for sponsoring today's webinar. And my final thanks goes to you, our audience. Thank you so much for being here with us today. If you, we would like you to please take a moment to fill out our post-webinar survey, and we hope to see you at a future Techstrong Learning webinar. Everyone have a great rest of your day.